Questions regarding heating and cooling curve. As you can see, I have drawn the graph and I have again mentioned A to B, C, D, E and then F. On the y-axis we have temperature and on the x-axis we have time, which is in minutes, and temperature is in degrees centigrade. So the questions I have written are: what is the melting point of wax? Number 2, how long will it take for all the wax to melt? Number 3, what is the boiling point of wax? Now as we see that it starts from 0 degrees centigrade and rising up. Now from A to B it's all solid. At B you can see the temperature becomes constant. This means that the change of state is taking place. Solid paraffin wax is changing now from solid to liquid, and till C the change of states take place, and we have both the states, that is solid and liquid. At C again you can see the temperature rises till D, and now at D point again we can see the temperature is constant, that is 150 degrees centigrade. Now at D the liquid has started to changing into vapors till E, then from E to F it is all vapors. So first static temperature is at 50, which is the melting point, and the second constant temperature is 150, which is the boiling point. And now there is another question: how long will it take for all the wax to melt? You can see that at 1 minute it starts melting, till 4 minutes it melts, and then the temperature rises. So if we count the time, it is 3 minutes altogether in which all the solid has been melted. Now we come to question number 2, and now this is a cooling curve. A molten compound is cooled to solidify. Molten means obviously that the compound is in liquid form. So there are 4 options, that is, when are liquid and solid both present? A, P to Q and R to S. B, P to Q. C, Q to R. D, R to S. Now as we can see that from Q to R the temperature is constant. This means change of state is taking place it starts from Q till R. So it is liquid from P to Q, and from Q to R now we have both liquid and solid. As the temperature is going down, the liquid is solidifying. So its answer is C. Now we have question number 3. Which graph shows the temperature change as steam at 110 degrees centigrade is cooled to minus 10 degrees centigrade? Now as we proceed, we know that boiling point of steam, water, is 100 degrees centigrade and its freezing point is 0 degrees centigrade. This means that at 100 degrees centigrade, the water is in the form of a gaseous state, that is steam. So when it is going to cool, it's going to change from gas to liquid and from liquid to then solid. So if we are cooling it till minus 10 degrees centigrade, the curve must show 2 levels as it is shown in B. Effect of molecular mass on the rate of diffusion. The rate at which a gas diffuses depends upon its relative molecular mass. As the particles are heavier, they will diffuse, their speed is going to be slow and they are going to diffuse slowly, as compared to the particles which are lesser in mass, they will move slowly. Now there is an example, that is when ammonia gas reacts with concentrated hydrochloric acid, it forms solid ammonium chloride. I have written the equation. NH3 stands for ammonia plus HCl. HCl stands for hydrogen chloride. When they both react, they form NH4Cl, that is ammonium chloride, which is in the form of solid. MR of ammonia is 17 and hydrochloric acid is 36.5. Ammonia is lighter than HCl. half the time lighter than HCl gas, so diffuses with double the speed of HCl. Let's follow the diagram. There is a glass tube, and in glass tube we can see on both sides it is closed, and we have cotton wool soaked in concentrated ammonia solution, and on the right hand side the cotton wool is soaked in concentrated hydrochloric acid. Red arrows, they show that is ammonia is diffusing towards the right side and hydrogen chloride is diffusing towards the left side, and they meet at a common point in this where there is written ammonium chloride solid. It's a white ring. We can see that the white cloud is formed near hydrogen chloride, reason being ammonia is lighter and travels faster and meet hydrogen chloride to form white ring near the end with HCl. Now in this question, it is very commonly asked in exams, this question, and there is one question which is asked that why ammonium chloride, the white ring, is not seen initially. It takes some time, for example, for ammonium chloride to get its concentration and become higher in concentration, and then only it is seen. So it takes some time when it is seen, not initially, not in the start. There is another process, that is diffusion of gases through porous spot. Diffusion of gases across the porous spot can decrease or increase the pressure in manometer. Now in this diagram, there are three diagrams I have drawn. These are the instruments. We can see that there is the U tube, which is manometer, and it has water inside it. Then there are three pots on the top. One is outer pot, then we have the porous pot inside, and then we have another jar inside. So there are three ones. Now the porous pot means that it has pores in it, and there is a jar, a gas jar outside, and there is a gas jar inside. Now as the gases, now in the first example you can see that in the outer jar we have ethene, and in the inner one we have carbon monoxide. I have written their MR, both have their MR 28 and 28. Now these are of the same masses, which means that the gases, they are moving in and out of the porous spots at the equal rate. So the pressure in the manometer will not change, and you can see that there is no change in the level of the water. Then we have second experiment, and here we can see that in the outer jar we have hydrogen, and in inner jar we have air. Air is heavier and hydrogen is lighter. So the hydrogen will diffuse at a higher rate, and it will enter the jar in which we have air, increasing the pressure in that jar, which drops the level of water in the U tube at point X. So the level falls in the left hand side of the U tube arm, manometer arm, and will rise on the right side. Now there is a third experiment, third example. It is opposite of the above one. In the outer jar we have air, and in the inner jar we have hydrogen. Now the hydrogen is going to diffuse out in the outer jar, thus decreasing the pressure in the tube at X level. So the level at X will rise, and on the right side it will fall. Thank you.